Hey guys, today we're going to talk about the rational root theorem / test. It can be called either one, and this is a really useful theorem, and it's used to develop a list of possible zeros for a polynomial. And if you remember, a zero is just when a polynomial goes through the y-axis. So you can figure out if a root is a zero by plugging it into the function, and if the y value that is returned is a zero, then you know it's right, that it's a root. So the possible roots are found by listing all the factors of the constant term over the factors of the leading coefficient, and that's what the rational root theorem says. The second bullet point is the definition of the rational root theorem. And the really important thing to notice is that the test does not give you the zeros of the function. It gives you a list of possible zeros that you can test for yourself. So the rational root theorem could give you 100 numbers, and what it says is that if there's a rational root, it's going to be one of these numbers. It's just a starting point. It's not the be-all, end-all of the question. It just gives you somewhere to start, and it really is helpful for getting started and figuring out the first few zeros, so then you can figure out the rest in a different method. So now let's look at how you use the rational root theorem and some applications of it. So here we have our example, and it says find all possible rational roots of the function x squared minus 2x minus 8. So now we're going to remember the rational root theorem. So let me write down here. It says that possible rational roots can be factors of the constant. So factors of the constant here. Constant is the 8, is the negative 8 actually. So factors of the constant divided by factors of the leading coefficient. I'll just write LC for that. So factors of LC. So we need to figure out this division problem, and then we have the possible rational roots. So the constant in this case is the negative 8, and the leading coefficient, if you remember, is just the coefficient in front of the largest degree. So the largest degree here is 2, so what is the coefficient in front of the x squared term? Well, it's 1. So the leading coefficient is 1. And now if you remember, the factor is just a number that can be divided evenly into the bigger number. So factors of 8 would include like 8, 1, 4, and 2, and that would be it. So now let's write factors of the constant, which is a negative 8. So you might be inclined to write, well, it's negative 4, negative 2, negative 1, and that was it, right? And then negative 8, of course. But don't be so quick to make them all negative, because you could also divide positive. Like negative 8 divided by 4 is negative 2. So what we need to do, and let me just cross these out really quick. I'll write 8, 4, 2, and 1, but then on the outside of them, I can just put a plus and minus symbol. And that's what we're often going to do for the rational root theorem. We'll just write all the factors and then put plus and minus just so you can identify to people that you realize that the numbers can be positive or negative, it doesn't matter. And then also for 1, the only factor is 1, but again, it's plus and minus 1. So these are the possible rational roots. So I'll write possible rational roots equal these numbers here. But it wants us to list them out, and I also want you to know how you do list these out. So first, let's make all the top positive and the bottom positive, and let's list out what we get from that. So we'll make I'll write possible rational roots, and we'll write it out as a list. So possible rational roots. If we're assuming that both the top and the bottom are in their positive forms. So it's positive 8 divided by 1 is 8, positive 4 divided by 1, 4, 2, and 1. So we made them all positive there. Now I'm going to make the top negative and the bottom positive. So we'll get negative 8, negative 4, negative 2, and then negative 1. And then now what if I made the top positive and the bottom negative? I would get 8 divided by negative 1, but I already have negative 8. Then I'd get 4 divided by negative 1. I already have negative 4. So if you see, now it's just going to start repeating. So really, these are all the possible rational roots. And if I wanted to, I could simplify it even more. I could just say plus and minus, and then write again just the 8, 4, 2, and 1. Because those are my 4 factors, 4 possible rational roots, but they can be in the positive or the negative form. So you can do either one. I personally like to do the first one the longer drawn out way, because then I can see them when I need to do the second question, which says find the rational roots of the function. So now that we figured out the possible ones, we have to be careful because the theorem does not say that these are the zeros. It says they are the possible ones. And if you remember, To test them, we have to plug it into the function and see what ones give us the value of 0. So let's rewrite our function. We have y equals x squared, if I can write x squared minus 2x minus 8. I think that's what it was. Let me check. Yeah, x squared minus 2x minus 8. Okay, and now I have a list of these possible rational roots. Now I just need to test each one individually. So I'll start with 8. So let's test 8 and see what I get. I would get 64 because it's 8 squared minus 2 times 8 is 16 minus 8. That's not going to give me 0. So 8's not a factor. Let's try 4. 16 minus 2 times 4 is 8 minus 8 equals 0. That looks good. That's a factor. That's a rational root, I should say, not a factor. So now let's do 2. So I get 4 minus 8. That's not going to equal 0, not a root. And then now I'll try 1. I would get 1 minus 2 minus 8. It's not going to equal 0, not a root. Now let's go over here and try our negatives. So negative 8. Negative 8 squared is going to be positive 64 minus, and now it's going to be 2 times negative 8. That's a positive 16. So plus 16 minus 8. It's not going to work out. Now let's try negative 4. So negative 4 squared is going to be positive 16. Then minus 2 times negative 4 is plus 8. Minus 8, that gives me 16, which is not 0. Not going to work. Negative 2. Negative 2 squared gives me positive 4. Minus 2 times negative 2 minus 8. All right, so let's see. 4 minus 2 times negative 2 gives me 4 plus 4. So 4 plus 4 is 8 minus 8 equals 0. That looks good. That's another root. And then now let's try negative 1 lastly. I'll get negative 1 squared, which is positive 1, minus 2 times negative 1, minus 8. Negative 1 minus 2 times negative 1, that's 1 plus 2 minus 3. That's not going to give me 0. So my two roots, so my rational roots, they're the ones that equaled 0. So rational roots are 4 and negative 2. So what you learn probably is that the rational root theorem does not do the work for you. It just gives you some examples to plug in and test. What you have to do then is go back and figure out which ones work and which ones don't. So that's what we did here. We listed all the possible rational roots, and then we figured out which ones were actually the rational roots. That's what the rational root theorem is good for. I hope this was able to help. Let me know if you have any questions. Thanks for watching.